vectors and modeling with vectors. Yeah, sure. No, this would be easy. A little mixture of kinematics from O levels. Basics, just the basics. Speed, velocity, distance. Less than that. Related to vectors, less than that. So modeling with vectors, you need to be able to use vectors to solve problems in the context. In mechanics, vector quantities have both magnitude and direction. For velocity, displacement, forces, you can also refer to magnitude of these vectors, scalar quantities, speed and distance. First, the worked example. A girl walked 2 kilometers east. So 2 kilometers towards east, you know where east is, north, south, east, west. So 2 kilometers to east from a fixed point O to A. So we get this OA and 2 kilometers. Then 3 kilometers due south from A. So now 3 kilometers down to B. Now we know this is A, this is B. Find the total distance traveled. So total distance we traveled is 2 plus 3, which is 5 kilometers. Then it says the position vector of B relative to O. Now this is the position vector. We know that OA is 2i. We know that AB is minus 3j. It is vertical and it is downwards. So for OB, position vector of B, OB is 2i minus 3j. So OB is equals to 2i minus 3j. Then the magnitude of OB, magnitude is always simple, x square plus y square whole square root. We have 2 and 3, so 2 square plus 3 square whole square root 4, 9 square root 13. The bearing of B from O. So how we deal with this bearing thing, you know that this is 2, this is 3. To find this angle theta, I can use tan. So tan theta is equals to 3 by 2 and theta is equals to tan inverse of 3 by 2. Okay, so tan inverse of 3 by 2 is just a second. Tan inverse of 3 by 2 is 56.3. So this angle right here is 56.3. But we are asked about the bearing. So bearing is this whole angle in red, this angle. So 90 plus 56.3 is equals to 146.3 degrees is the bearing. So this is modeling of vectors. And let's come to few questions. Exercise 11F. Find the speed of the particle moving with these velocities. So we have exercise 11F, question number 1A. Now you know this is 3i plus 4j. If find the speed of particles with these velocities. A particle is moving in this direction, that is 3i. The main question is 3i plus 4j. So 3i plus 4j. This would look like this, and this is the resultant. So this would be 3 square plus 4 square whole under the root. So that is 5 meters per second. In case of 24/7 B part, it is 24i minus 7j. So this would look like 24i in positive direction, 7 in negative direction, and this is your resultant. So 24 square plus 7 square whole square root is, what is it, 24 square plus 7 square is 625. So square root of 625 is 25. Getting it? Question number 2 says, find the distance moved by the particle which travels for this 5 hours at a velocity of 8 plus 6. Now we know 8i is this and 6j is this. So applying Pythagoras theorem, 8 square plus 6 square whole square root 64 plus 36, we get square root of 100, that is 10. So this is 10 kilometers per hour. Now something is traveling for 10 kilometers per hour for 5 hours. So distance is equals to speed into time. Speed is 10 and time is 5. So it covered 50 kilometers. D part, question 2, D part. Time is 2 minutes and velocity is minus 4i minus 7j, and we have to find the distance. Now minus, yes Mohammed, we have to use compatible units. Look at this, kilometers per hour with hours, kilometer per second with seconds. This should be compatible. When you multiply with them, with these two, hour cancels with hour and you're left with kilometers, second cancels with second and you're left with kilometers. This speed right here was in kilometers per hour and this time was in hours. So this hour got cancelled with this hour and you're left with kilometers. In this D part, I selected this D part for the same reason. This is minutes, but you see the speed is in centimeter and second. Here we will need to change this. In A part, all the units were compatible. Look at B part. This again is in seconds. The speed is also in seconds, so no issue. Let me complete, you will be comfortable. This is 4, 7. That's good. So 7 square plus 4 square whole square root. 7 squared plus 4 squared is 65. So that is square root 65. Now we know the speed. So distance is equals to speed into time. Now my speed is square root 65, which is in centimeters per second, and time is in minutes. Time was 2 minutes, so I'll multiply with 60 to convert it into seconds. Now everything is in seconds. So square root 65 times 2 times 60 is 967 centimeters. Question number 3. Find the speed and the distance traveled by the particles moving in a straight line with. This is same. This is speed and time again. It is exactly same as question number 2. Only you have to be careful with these units. These are meters per second, seconds, no issue. Kilometer per hour, no issues. Now look at this D part. Let's do this. This is kilometer per hour and this is minutes. So question 3, D part. Velocity is x is 12y, positive 12y and minus 5j. So 12 and 5, we use Pythagoras theorem to find the third side. Let's say this is x, so x square is equals to 12 square plus 5 square. X square is equals to 144 plus 25. X square is equals to 169. Square root both sides, x is equals to 13. Now this is 13 and distance is equals to speed into time. Distance is unknown, speed is 13 and time is 30. Now see, speed is kilometers per hour, time is minutes. If I divide it with 60, I convert it into hours. 3 1 times, 3 2 times, 13 by 2, or we write 6.5 kilometers. So it traveled 6.5 kilometers. Question 4. A particle P is accelerating at a constant speed. When t is equals to 0, the particle has velocity u. At time t is equals to 5, particle has velocity this. The acceleration equation of the particle is given by the formula. Acceleration is v minus u over t. Find the acceleration of the particle. So first we need to find v and u, v minus u by t. There are two ways how we can do this. Either directly, let's go with the formula directly. Acceleration is v minus u over t. So just plug in v, that is 16i minus 5j minus u. U is given, which is 2i plus 3j and divided by time, that is 5. Time is 5, u is given, v is given. So acceleration is 16i minus 5j minus 2i minus 3j over 5. So 16 minus 2 is 14i. Minus 5 minus 3 is minus 8j over 5. So either you write it this way or you split it into 2. It's better you separate I and j. This is the acceleration in terms of I and j. Okay, now mass is being involved. From kinematics we are going into dynamics. Question number 5. A particle P of mass m is equals to 0.3 kgs. 0.3 kg mass is given. Moves under the action of yes, Mohammed. No issues. Under the action of constant force F newtons. The acceleration of P is 5i plus 7j. Acceleration is 5i plus 7j. Find the angle between the acceleration and I. Okay, first part, angle between acceleration and I. So if I sketch it, we know that this is 5i and 7j. So direction is basically this. So angle between the acceleration and I is the horizontal part, so this theta is to be found. So tan theta is equals to perpendicular over base. Theta is equals to tan inverse 7 by 5. So shift tan 7 by 5. Theta is 54.5 to 1 decimal place. So angle between acceleration and I is 54.5. Force and mass Force, mass and acceleration are related by the equation F equals ma. Find the magnitude of force. So F is equals to ma. We know that mass is 0.3 as given in this question, and this is the acceleration. So I'm going to find the magnitude of this acceleration, which is 5 square plus 7 square whole square root, using this 5 and 7, or you can say we brought it from IJ form. So 25 plus 49 is 74. So this is square root 74. And you get 2.58 newtons. Mass was in kgs, acceleration in meter per second square, so force is in newtons, 2.58. Question number 6 says two forces F1 and F2 are given. 1, 2. The resultant is F1 plus F2 acts in a direction which is parallel to the vector 2i minus j. Find the angle between R and I. Okay, first we will find R and then we will talk about the angle. But we can directly solve it because it is given that it is parallel to this vector, right? So this is 2i and minus j. We can find R later and we can just answer this question directly. Are you getting it, or I'm solving it alone? Yes. It said two forces F1 and F2 are given by the forces. F is given and F2 is also given, and we can see F2 is basically unknown, Pi plus Qj. Then it says the resultant forces R is equals to F1 plus F2, and it acts in the direction which is parallel to this vector. So whatever R is, because that is unknown because of P and Q, but it is parallel to 2i minus j, and 2i minus j will look like this. This is 2i, this is minus j. So this is 2i and minus j, and R is parallel to this. So parallel vectors would have same direction and will have same angle. So it says find the angle between R and vector I. I is the horizontal. So this is the angle we need to find. So tan theta is equals to perpendicular over base. Theta is equals to tan inverse of 1 by 2. It is 26.5. So this is your angle with horizontal. B part says that show that P plus 2Q is 5. So we just use the given equation. It said R is equals to F1 plus F2. And F1 was 3i minus 4j. And F2 was, this was Pi plus Qj, and one more thing which we know is it is parallel to 2i minus j. Now see, if I solve for R, this is 3 plus Pi and this is Q minus 4j. Do you get it? Just combine I with I and j with j. Just for the ease, I'm writing it in column vector form. This is 3 plus P and this is Q minus 4, which is actually parallel to this, that is 2 minus 1. If they are parallel vectors, vector A, vector B, if they are parallel vectors, they must be connected with the equation b is equals to a is equals to h times b, sometimes 1 time, 2 time, 3 time, or half or something. So we can just write it this way: 3 plus p q minus 4 is equals to h times 2 minus 1. Or one I just clicked. We have to show that p plus 2q is equals to 5. I missed that part and I took the longer path. Easier would be that 3 plus p divided by 2 is equal to q minus 4 divided by minus 1. So we just cross multiply, minus 3p is equals to 2q minus 8, and rearranging, sorry, 3p, that is minus 3 minus p, and then rearranging, minus p is equals to bringing q also on this side, minus p minus 2q is equals to 3 minus 8. Yes, I'll repeat. I'll repeat. And no issues, just let me collect the data on one side, it would be easy. F1 is equals to 3i minus 4j, first thing. F2 is equals to pi plus qj, that's unknown. And R is equals to F1 plus F2. And it is given that it is parallel to 2i minus j. This was the question. So R is parallel to 2i minus j. So first part was to find the angle of R and I axis. So this is 2i minus j. This is 2i minus j. Whatever R is, suppose R is this, it is parallel to this part. So if I need to find the angle of R and I, angle between R and I, it would be exactly same as between 2i minus j and I, because they are parallel. So what we did for this theta, that is tan theta is equals to perpendicular over base, and theta came out to be 26.5. This was the first part. Second part said that show that p plus 2q is equals to 5. So if they are parallel, first we found R, that was adding these two vectors f1 plus f2. So if you add them, you get 3 plus p I and q minus 4j. Now we know that these two are actually parallel. So I'm dividing I with I and j with j, so to make a similar triangle. If I draw R with this green color, see if I extend this, so this will look like this, that this is R part, this is the x portion, and this is the y portion. So they are similar, they are parallel, so they are in ratio. So 3 plus p divided by 2 is equals to q minus 4 divided by minus 1. What did we do? We divided I part with I part, and we divided j part with j part. Then cross multiply, minus 3 minus p is equals to 2q minus 8. Taking p on the other side, p plus 2q, bringing 8 on left hand side is minus 3 plus 8. So 5 is equals to p plus 2q. Got it? Yes, I is given. Okay, question number 7. The diagram shows the sketch of a field in the shape of triangle ABC. AB is 30i plus 40j. AC is 40i minus 60j, and BC is unknown. When we have to find BC, we travel from B to A, then A to C. AB was given, AC was given. So for BC, looking at the diagram, I can write BA plus AC. So we just copy BA but with negative sign. So negative of 30i plus 40j and plus AC. Straight away there's no change in direction, so 40i minus 60j. Simplifying, minus 30i minus 40j plus 40i minus 60j. I will left with 10i and j with j minus 100j. So this is BC. Second part says find the size of BAC. BAC. Okay, BAC, we need to find this angle and look at these marks, 4 marks. I'm just copying it here to avoid any sort of confusion. Let me just quickly write this. This was 30i plus 40j. This is 100i minus 10i minus 100j. And the third one is 40i minus 60j. Now we need to find this angle, and this is a 4-mark question. I'm looking at this triangle as if I know all the 3 sides. If I know them, I can use cos rule. So for this part, this is 30 square plus 40 square whole under the root, and that is 50. So the length of this part is 50. Now this part, this is 40 square plus 60 square whole under the root. I'm finding magnitudes. Are you getting it? So 40 square plus 60 squared, this is square root 5200, or simplified to 20 square root 13. So we know this side too, and for the third side it is 10 square plus 100 square whole square root 10 square plus 100 square, and square root answer is 10 square root 101. 10 square root 101. This is the third side. Tag. Now we can simply apply cos rule on this. 10 square root 101, 50, 20 square root 13. Angle. Yes, angle between these 2 sides. This was BAC. Do with what? Okay. So BAC, we are finding this angle. Now we know all the 3 sides, so we can directly use cos rule. So cos theta is equals to 10 square root 101 whole squared minus 50 square minus 20 square root 13 square over 20 square root 2 into the remaining 2 sides. Cos theta is equals to a square. You will have some formulas, not all. Probably given. Probably given. I'll double check it. This is in two ways. This is in two ways. One is this case. The other is cos theta is equals to b square plus c square minus a square divided by 2bc. Be careful with the negative signs. So minus 2b and c square 2bc. Then we follow what the calculator has to say. So this is 10 square root 101 whole squared minus 50 squared minus 20 square root 13 whole square divided by minus 2 into 50 into 20 square root 13, and this is negative 0.33 cos theta, and theta is equals to cos inverse of negative 0.33. So shift cos of answer, and the angle is 109.4. This was one method. There is one other method. For case of vectors, what we do is first vector and second vector. You have to be careful when you're finding this angle. Both the vectors must be going away from this point or coming towards this point. So if you have this, what was this? The labeling ABC. If you have this vector AB this direction and AC in this direction, then it is fine. If one of the vectors is switched, you'll have to do it again with the right direction. Both must be leaving, converging or diverging. So the other way to do this is vector form. This is 30i plus 40j, and this is 40i minus 60j, and it is in the correct direction. So the other way was cos theta is equals to a dot b divided by magnitude of a into magnitude of b. So a dot b, this is vector a 30 40 dot vector b 40 minus 60 divided by magnitude of a and magnitude of b. I'm saving time, we've already done it. So that was 50 and 20 square root 13. So this is 50 and this is 20 square root 13 is equals to, yes, we've already done this. This is method 2. So dot product of vectors, dot product of methods. So 13 to 40 is 1200. Hi, yeah. Okay, so this is 1000 square root 13. I just hope we get the same answer. So minus 1200 over 1000 square root 13. We get it with these two, and we left with minus 12 divided by 10 square root 13. Okay, minus 12 divided by 10 square root 13, and yes, we are getting the same answer. So minus 0.33, and again cos inverse of this, we get 109.4 up to 1 decimal place. And then I'll leave something for you to practice, like question 8 and then mixed exercise. Obviously mixture of whatever we did in the previous exercises. And here's the summary. If two vectors are equal, they are equal in length and are parallel. Point number 2 is just the opposite of that. Triangle law AB plus BC is obviously equal to AC. The common point disappears and the resultant is first and last number. Subtraction, addition of vectors, scalar multiple like A, 2A, 3A. It is parallel but 2 times or 3 times in size. IJ, representation of IJ, 2-dimensional in column vector form or IJ form. The magnitude is x square plus y square whole square root. Unit vector is actual vector divided by the magnitude. Position vector is the direction from the origin, that is basically the coordinates. And position vector are always split in this way: second variable minus first, OB minus OA. And this is the ratio thing we did. With lambda and mu it is tough to understand. With numbers it is very easy. If this is 2 and this is 3, so it wrote OP for OP. We know for OP we can say OA plus AP. So OA plus AP. Now what actually AP is? OA stays there. Compare it with this thing. OA stays there, but AP is 3 out of 5, which is actually sum of 3 and 2 of the complete length AB. So don't get confused with this pi and mu. This is just the ratio between them. And if A and B are non-parallel vectors, and it is given, yes Mohammed, that's just an example. It is easy to understand with numbers. If I change this with 13 and 12, this is how it changes. It is easy to understand with this, like 13 out of 25, but lambda out of lambda plus mu is difficult to understand. So this was it. Then you have the mixed exercise. Please go to the practice part and we'll discuss.